So especially my lecture, it's all about to discuss our concept in the virtual learning university. As you know, first of all, the courses are free of charge. And we have many lecturers giving talks. And I want to explain today how we are working and what is the concept of our university. But it's not just to do business or just to attract people, but also to talk about solar, and especially photovoltaic, where I worked since more than 35 years. So if you want me to give the talk in French or in any other language, I can do it also. But since we are today in English, maybe it's better to continue in English. So what they call here online learning series, connecting with students. I want just to connect with students and to explain how we are working in this university and what we are doing exactly. And with particular interest to my syllabus. Okay. So you have here on the screen all the internet page and also the email where you can reach me, etc. It's also on Facebook and so on, and LinkedIn. Okay. But let's start with this. All you know about the carbon footprint and the global warming. You heard about it. And you also always, the politic says always we have only one planet. There is now planet B. لا يوجد كوكب باء. And actually, if we look to this diagram here, you see the amount of carbon in the atmosphere. It's more than 50 billion tons of carbon oxide. And I just put here some data if you want to know how we calculate the carbon oxide. So we just use the weight, the atomic weight of carbon oxide, and we do some small calculation. But this you will find it everywhere in Google. I don't want to. I will do it when I am giving my course, this kind of calculation. So actually, imagine that we go business as usual. نستمر في نفس المسار. So we will increase the carbon dioxide, ثاني أكسيد الكربون. And of course, that's what we are doing actually, because we use a lot of oil. If you look to this, this is a little bit old, but it can tell us the reality. So we have only maybe now 10% of renewable energy we have, maybe. Here I wrote 4% because it's a little bit old, maybe 5 to 10 years old. So actually, we are going in this direction here, business as usual. This means the temperature of the Earth will increase. Okay? We have to find other solution to stop this carbon in the atmosphere, or carbon dioxide, or other greenhouse effect as well. So we can keep what we have now and to do a lot of technology to recycle what we have already now, to fix it, to use it in industry, but we hold here. That's one possibility. The best possibility, of course, is to cut completely and to use what we call cut the emission circular carbon economy. And of course, we have to use some technology that run on green fuel. So actually, we have technology that run on fossil fuel, and we have to run technologies that run on green fuels if we want to have this green here. This means we have to decrease this amount of carbon in the atmosphere. So this we need to remove carbon dioxide in the atmosphere, to recycle it and to reuse it. And of course, we have to use green energy for that. So our course is based on this. So we want to give course. We have two sections in Virtual Learning University. One is politics and journalism. And Dr. Jamila, she's a PhD in law and rules, and she's taking care of this section 2. And me, I am taking care of the section 1 together with the Ustad Salih. So how we are working to make our syllabus. I just put here the Mendeleev table, which contain all elements in the earth. And we know everything about this Mendeleev table as a physicist or chemist or physical chemist. And we say, okay, we will build up syllabi based on industry need. مناهج بناء على الاحتياجات الصناعية. So, and we will go forward. And I think we have a lecture or a syllabus about this, where physicists and chemists are working for the evaluation through simulation and modeling. New material for batteries, new material for PV, new material for different, for catalysts for the hydrogen production, etc., etc. And we build up knowledge. We develop knowledge. Then, of course, if you work with simulation and modeling, you can find plenty of materials, devices, etc. But you have to take into consideration the economic, the cost. And also we will work on this to narrow down the choose based on processing and economic. So the processing and the economic to see what is possible according to our economy. Then we have to identify suitable material. تحديد مواد مناسبة دقيقة. That's another issue where we start to work on research and development, R&D. Then we have to identify failure mechanism. When you have a material, you have a device, the device has to be stable. The device has to work for many years. And therefore we have to work like this. So that's how we work. So this concept, what we have done here, until to find a proof of concept. إثبات الفكرة بهدف معاينة إمكانية التطبيق. What we call a proof of concept. If you have a proof of concept, you have to find industry which is interested in your product. But you have to reach a specific technology readiness level from 6 to 9. This is this metric what the NASA have developed since long time, which is, I find, very interesting. And once you have the industry and you develop your proof of concept to commercial product, of course you will go to the industry. So in this exercise here, we go from atom, density function theory, quantum mechanics, and statistical physics, etc., simulation and modeling based on this. And we work for technology development and business development to make, for example, solar cell or battery and whatever. That's our philosophy in the Virtual Learning University. Okay. So now how our student will enroll in our course. they have just to go to the web page. We have a lot of video, a lot of syllabus. They can read the syllabus, they can see the video, and they can think about that they are interested in one course, PV technology and balance of system, or the storage using lithium batteries, whatever. There are many. If you go to the platform, to our web page, you will find all this. Of course, we start to open a course only if we have more than 30 attendees. We cannot open for less, maybe 29, 28 is fine. We can actually deliver a certificate, but only signed by the professor who gave the talk and the university. Okay. So that's how we are working. There is a course I show you here, for example, Professor Ben Yusuf. I think he's there, and he will give a talk tomorrow. He's in charge, and he has 40 years experience on ab initio, on density function theory, quantum mechanics, statistical physics. He comes from the best school in Paris. And you can go to the web page, you see video, you can register in his course, you can see his lecture, his syllabus, and you can decide if you want to go to this to his course. And we always work in this direction, from knowledge development to research and development to proof of concept, until a certain level of technology readiness level. And of course, we push students to go to startup and to industry product. That's our philosophy in this university. I have also a course, what we call PV technology and balance of system. And I teach the PV technology, the power to X, building integration photovoltaic, digitalization. And this course, you can register, and if there are enough students, we can open the school. Diploma engineer Badr Ikan also, he proposed a syllabus on social entrepreneurship and sustainable development. I think today you have heard about the entrepreneurship from Ismail Aqlai, and you know what it is. So this is also another, of course, and always in the same philosophy. There is another course from, for example, from Ismail Sadoun. He's from University Qadi Iyad, and he's one of the best professor in Morocco about working on lithium batteries. And he offers a course on lithium batteries from atom to device. And there is a video about his lecture, and there is also the syllabus, his syllabus. You can read it, and you can register in his course. So, and there are many other courses where you can go and register. Now, if I just talk about my course, which is PV technology and the balance of system, I start first with material energy, the material which can be used for energy. I have to explain this before going to the technology. This is, for example, the most important relationship which gave you the power, what you can get from solar spectrum. So you have a solar spectrum, and you have to find materials. You optimize the materials in terms of band gap, in terms of physical properties, that you can absorb the maximum of the light intensity to have the maximum of power here. And this maximum of power, this point here, this maximum power point is the product of the current by the voltage. And this 1000 watt per square meter is the air mass 1.5, what you get from the sun, which is very well known. And this will be discussed in my course, of course. And of course, we always try to optimize material in order to get to the Schottky-Kaiser limit. This means the maximum or the efficiency, which is approaching the theoretical efficiency. So all knowledge development about this background here will be developed. Here, for example, we will explain to the student how to make a tandem cell using the part of the solar spectrum for a large band gap and for a low band gap to make it together to get it in order to get the maximum of energy here. We also explain to the student every single element of this device. For example, for silicon wafer technology, you have many issues here which we will be discussed. So in order that you can collect the maximum of the current and the maximum of the voltage, and therefore you have the maximum power. So our course go in this direction. That's how we are working. So all knowledge development regarding this issue will be developed in the course. One of the problem, which is very important, will be also very well studied in our case, is the effect of temperature. You know, whatever you buy module, when you go to the hot climate, you know that the efficiency will decrease with the temperature, and how to resolve this kind of problem. And we will discuss this very carefully in our course. Okay. I will go a little bit very fast here. So every element here regarding the solar cell and the PV technology will be discussed in this course. And we will see how the temperature affect the voltage. The current will not be affected very much. They will increase a little bit, but not very much. But the voltage will decrease with the temperature. And we have to define what we call NOCT, the nominal operating cell temperature. So we will also go inside the solar cell and learn how, going from the technology, for example, here is the technology of silicon, where you have the front contact, the back contact, you have different elements in the front, in the back contact, how to make the equivalent circuit of your solar cell. And this will be very well discussed. And for engineers, this kind of relationship or equivalent circuit are very important. Okay. We will also study the real solar cell, where you have a shunt resistance and series resistance, and you have also a factor here, which the ideality factor. All these elements will be studied. After the silicon, we will study also other technology. For example, if you go from silicon, which is the element of the Mendeleev table, and the silicon, as you know, it can be doped very easily with p-type or n-type. For example, if you take here silicon, which is in the fourth column, you can dope it with phosphor. This means you have one more electron, extra electron, or you can dope it with bore, for example. That's the most common doping for silicon. So you can have a P-type or N-type material. So it's very easy material. But if you go to another element like 3,5 compound or 2,6 compound, the problem is complicated. So all this knowledge regarding this will be studied in our in this PV technology and balance of system. And we will go further for element for for ternary compound like chalcopyrite. That's one material that I have studied more than 25 years, and we will discuss, for example, how to go from silicon to zinc sulfide or zinc blend structure to chalcopyrite to kiesterite. All this zinc will be studied. So it's advanced courses. We go very slowly from very simple stuff to very advanced courses. And we will develop here what I call the knowledge development, which is very important at the university. Okay. When you understand, you have enough knowledge and you understand the background, the technology is very easy. The technology is very simple. The most important is the knowledge. Here, for example, is how to build up the material like copper, indium, gallium selenide. I don't know if I can see here the so if you take, for example, the copper, indium, gallium, and sulfur, and selenium. That's one material where you can prepare it, what we call by evaporation or sputtering, and then some annealing, what we call rapid thermal processing. And this kind of, you can make this kind of structure here, what you see. You have the material here, you have, then you have to add cadmium sulfide and zinc sulfide, or zinc sulfide and zinc oxide, etc. And this technology is very interesting, what we call interconnected devices here. So first, you deposit pieces of molybdenum. This is just to show you how the technology is working. Then with a laser, you can cut this molybdenum. Then you deposit this copper, indium, gallium sulfide selenide, as you see here. Then you cut again this material. And by doing this, you will be able already to predict how much voltage with your module you can get by adding monolithically the different pieces of this material, by making this patterning here, P1 and P2. And then you can finish with another material like zinc sulfide or cadmium sulfide, and then you can get your device. And this technology, what I work on it for many years, and it can actually, the price of silicon is lower because the market of silicon was completely taken by Chinese, and they make everything cheap. That's why this technology is still a little bit, it's very slow, or the market for this material, for this module, 10 film CIGS became unfortunately, all industry in Germany, they stop because there is a competition with silicon. But I believe in the future, it will come. So this kind of technology is very important for integration, for building integration photovoltaic, where the back contact of one cell is connected to the front contact of another cell, and you can have as much voltage you want. And this is very interesting. So this kind of technology also we will study. So my program in this PV technology balance system, after the knowledge development and after the studying different technology, silicon technology, thin film technology, like the one I just showed you with copper indium gallium sulfide selenide, we will go directly to the system in order to study the balance of system. This is very, very much important. So how to connect your solar cells with batteries, with this is written in French, but in inverter, etc., and how to integrate your module into your home, and even to inject the electricity if you have a surplus of electricity to the grid, etc. All this problematic we'll discuss. So the course go from atom in the beginning, where you have to make simulation and modeling to understand the physics of the material and device, and go slowly until the balance of system, where you have to connect your module with different elements here, like the inverter, etc., etc. So that's engineering. And here are different parts of the course, as you see. We start with solar radiation first, because you have to know it. You have to know the silicon, the physics of silicon, and the technology of the wafers, the manufacturing of silicon, then thin film technology, and then all other generation, and the performance of the cells and module, etc., etc., and the economic also. We try to, in this virtual learning university, to prepare ourselves for the future. This means we know what's going on in Europe and United States, how things are organized, and we try to make the amount of hours for every item here, in order that in the future, if one day our virtual university will be affiliated to a university in Europe or in Morocco, why not? Then we don't have that much to change. We are planning to work 2 semesters, one winter semester and one summer semester, like in Europe. I talked the model of Germany, but I think in France and in everywhere it's the same. You have two semesters, winter semester and summer semester. And we try also to follow the rule of big university like Stanford, like in France or in Germany, where you have a homework, middle exam, and final exam. So it's about the same like what's happened. And the objective is to be aligned with the European credit transfer and accumulation system, what we call ECTS. So one day, if a student, he got his course in virtual learning university, he can use it if he go to Europe or to United States. That's our path or our roadmap. So we are focusing how to have a very good course which is acceptable in Europe and in United States and maybe in England, even if there is a Brexit now. Okay. Then we have a project. We have project. So the objective of this solar project is to deliver greater efficiency, there is somebody, he told me that there is now I will look. It looked like if there is no.
You are muted, Prof. Ahmed.
Since the beginning? Since the beginning, it's muted or what?
Now it's okay. A few seconds.
But the whole time was muted, is it?
No, it was okay. It was okay. Only the 10 seconds.
Okay. Then I'm happy that it's like this. So do you see now the slide?
Yes.
Okay. So let's continue. So in addition to knowledge development and technology development, we have we plan some project, and the objective of this project is to deliver greater efficiency per watt to customer. I call it like this. This means we have to work on the efficiency per watt in terms of cost, in terms of value, etc. So we have project about the home solar PV project, what we call like this. So, for example, your house or your home, you want to have to install photovoltaic. So how much you need, how much module you will buy, and how to connect the module with inverter, etc., in order to have the best connection and the best efficiency. So this is for home, for your home, also for commercial and industrial project, if you have a big project, and also for building integration photovoltaic. As you see here in this animation, you can work with architect from the beginning of when you build your house or your project, in order to have the energy efficiency, the right one. If you want to install the PV from the beginning by integrating into the building, so you start from the skeleton of your building, and you start to plan with the engineer and with the architect. And this exercise is very important, very important. That it's not a question that to know the physics of solar cell. You have also to know how to work with the architect. You have to know how to work with the builder, and you have to know how, if you have a customer, if you have a company, how to manage all this stuff. That's why we have in the beginning start to add to our virtual university the entrepreneurship. So you need to work with all these people. Financial institution like bank, contractor, installer, equipment manufacturer, home owner, all this is very important. So you have to be an entrepreneur. Okay. Of course, you have to know how to use what we call the characteristic of every device. You see here, that's for the inverter. There are many characteristics. You have to know how to read this and how it works, how to calculate all these numbers. Also for the module, etc. And to know how to use this kind of relationship, which give you the annual electrical energy. So it's not theoretical stuff, but it's from theory. We start from theory and we go until the engineering. Okay. Then photovoltaic alone is not enough. We have to to know how to use it for other application. And here, for example, for the decarbonation, for the energy transition, we have to think how to produce hydrogen, for example. And this is also part of our course to study the electrolyzer, for example, how it's working, the electrolyzer, how to get an efficient electrolyzer by adding the catalyst. And the catalyst has to be studied from the beginning, from modulation, from by modeling the material from the Mendeleev table you start. And this is very important, because if you want to have an efficient hydrogen production, your electrodes, the anode and the cathode of your electrolyzer, has to be coated with some catalyst, which facilitate the chemical reaction. We have to also to work on hydrogen storage, like the hydrure, for example, where you can store hydrogen. We will also develop the fuel cell, where you can put oxygen from the atmosphere and hydrogen from electrolyzer, and you can produce electricity where you can use in an electrical car, for example. So all these are included in this course. So new membrane, new catalyst, and new storage alloys. So that's really a portfolio of research and development. Then the fixation of carbon dioxide. It's a very important issue where we will study in this course. How to remove, how to recycle, and how to reuse carbon dioxide. Okay, so all this issue will be studied. We will also explain how to produce, how to use hydrogen, green hydrogen, and to cap the carbon dioxide from the industry to fabricate, for example, methane or other green fuel. Also, we will study the Haber-Bosch process, where you can use nitrogen and hydrogen to fabricate the fertilizers also. So that's really it's not just a course for just a course, but it's really a course to resolve problems. So I'm not going to give more detail here. We will do it if I am giving my course, but all these issues regarding the production of hydrogen and the fixation of CO2 will be studied. The difficulties of the production of hydrogen is the fact that the chemical reaction to produce hydrogen need 4 electrons. That's the big problem. That's why you need a catalyst. 1 electron, maybe it's very easy, but if you have 4 electrons to split water into hydrogen and oxygen, and you need 4 holes, let's see 4 electrons, you need a catalyst for 4 electron transfer. And then there is a cost. Actually, platinum is very expensive. We have to find a new material. That's why the simulation and modeling is very important. Another topic where I work very hard there is to use inkjet printing, for example. This is also another topic where I will develop in my course in order to learn how to make formulation of ink and how to deposit this ink in order to make solar cells on flexible substrate. And this will be also studied. I worked on this many years, and I have a very good student from China. They work on this project, and we will continue this work. There are many publications we did in this topic. This also will be studied. We will also study how to understand the problematic of carbon fixation or or why it's very difficult to fix carbon dioxide. And we will show to the student all methods which are used to resolve this kind of problem. This is also we will start. It's a very complicated problem which needs chemistry and physics, and this is one of our advantage that we know a lot in this project, in this stuff. So I will thank you very much that you follow with me this, but please keep in mind this is not a conference. It's just to show you a panorama of this course, what I call PV technology and balance of system, where we will work on fundamental problem from atom to material to device to system, and including PV technology, different PV technology, silicon technology, second generation, which I take as example copernadium gallium sulfide selenide. Then how, if a guy he's not interested in this fundamental, he went directly, he's interested in engineering, he want to make a company where he buy a module and he connect module on rooftop, and he will buy inverter, he will buy regulator, batteries. He will also find in this course what he need, and also hydrogen, green hydrogen or power to X. That's the objective of this course. And this course is related very much to the course of Professor Benius. He will be tomorrow in Casablanca. He talk about new generation of material for energy and storage, and also connected to the course of Saadoun, who he also has a course on batteries, lithium batteries. And we will, there are also other colleagues like Tariq from Tanji, where he's very much working on catalyst. He's a chemist, very good on catalyst also. His course also is very important for us. And if you go to the web page, you will find all these important stuff. Just go there, watch the video, read the syllabus, and decide if you are interested. You can enroll in one of these courses. So thank you very much. I finish with this course today. I will start a series of courses. If you are interested, you have to send me an email, or if you are in Casablanca, you can give your name to Dr. Jamila there, or you go directly to my email. There is an email. I show you this email in the beginning. I can go back to my first slide to see, I think there is here, the email. Yeah, this is the email. So it's a vluplatform@gmail.com. And you can send me an email, and then you can be with us. Of course, there are many things for people in Casablanca. There are some posters where we explain what we are doing. We have also some virtual lab with some colleagues. They are working on it, and all these are very important. It's the future. The virtual universities, I say universities, not university, will be the future in Morocco and over the world. So you can sit at home and you can learn, and you can go to the affiliated university where you can make your exam, or you spend some time. We are actually in the beginning. We are not affiliated to any university, but I hope in the future we will be affiliated to one of big university. This will depend only on us. If any university in Europe or in the United States, they see what we are doing and they see how much we are good, then we will find an affiliated university, and the people enrolled in our course will have a diploma from some good university. So thank you very much. And my lecture for today is finished. I will meet you after tomorrow to start with one research presentation. So Dr. Salim.
Thank you, Prof. Ahmed, for your presentation and giving the highlight to the courses for the Virtual Learning University. It's really an important who wants to participate. It is really, you will gain a lot. At the end, we thanks all the speakers and the attendees who participated in the first day of the Virtual Learning University Conference, day one. So inshallah, we are going to meet tomorrow, 8th of June. Prof. Ahmed, I will let the end for you, as usual, to end our session.
Okay, so tomorrow we have another program. I don't know if I will show you here this program. Do we have time for that?
We have around 12 minutes.
So let's see if I can show you the program. I still, okay, I will stop this first and then go to the program and to see if I can show it. It's a little bit difficult, but let's see, yeah? Let's see.
Yeah.
So tomorrow is the 8th. Okay, 8. Okay, 8. I don't see the 8. Well, what's going on? Okay.
I have it. You want me to?
Just give me one second. 1 second.
Go ahead, Prof.
So I don't know if I can show this. Wait a second. I will again go to this and then to that. Are you able to see the table?
Yes.
Do you see it all?
It is there.
Okay, so this is the program of tomorrow. I hope it's maybe it's too small. So you have in the morning 3 presentation, which will be in Casablanca. This means the person will be there. So there is Sayyida Latifa Nafil, Sayyida Jamila, Dr. Jamila Murabit, والسيد Dr. Muhammad Hilmi. They will give talks in Arabic. And then there is a lady from Egypt, Shayma Muhammad Sirqawi, Dr. Shayma. She will also give a talk, but via Zoom. Then there is Professor Ben Yusuf, as I told before. He will be at 2:30, and he will be also there, Hudori, and he will. I think it's very important. He will talk about the nano materials for hydrogen, for green hydrogen, and he will give his talk in Arabic. It's very important that you know that our professor in Morocco, when they are very good, they are also able to speak in Arabic, in French, in English, in every language, and to express science. And he will give a talk in Arabic about 2D materials, etc. And it's very important. I recommend for people that are in Casablanca to go there. Then afterward, at 3:30, there is a friend and colleague, Professor Ahmed Legrouri. He's in Africa, I think in Côte d'Ivoire, and he will give a talk about the quality of higher education and scientific research to serve Africa development. It's very important to know this. We are in the same boat, we and African, our African friend, and we have to know how things is working in Africa. Then there is one young doctor. He's very, very good in modeling, in engineering. He will give a talk on performance and durability, the system photovoltaic au Maroc. He will give it in French. And then from Belgium, our friend Dr. Ahmed Rasili, he's member of the VLU, and he will talk about recycling. He has a lot of experience in Belgium about the recycling of metals and waste management. So that's the program for tomorrow, and just go ahead and go to the Zoom and give your name and your email and etc. What is required, and then you are there. So that's all what I can tell you for this, and I will go to Dr. Salim Omar.
Thanks, Prof. If there is any question at the end from any of the participants, you can raise your hand so that we can
so if there is anything about VLU, somebody want to ask, I'm here. Yeah.
Okay. Let me check there. All thanks to all the speakers and the management and the organizer. Thank you to you all. So I think we reached to the end of today. It was an enjoyable and mashallah. Prof. Abdul Ilah, you are there. You can open your mic, please. Yes.
شكرا جزيلا أستاذ دكتور سالم والزميل أحمد على هذا اليوم الغني بمحاضرات. شكرا جزيلا، وإلى اللقاء غدا إن شاء الله. شكرا على التنظيم، حسن التنظيم. شكرا.
شكرا لك بروف أحمد. الله يسلمك عبد الإله. إذن really we are happy. We want to stay more, but tomorrow we are going to meet inshallah, and it will continue today from morning 10:30 up to 7 online inshallah. So see you.
Thank you very much. Thank you.
Thank you. Ma salama.